Okay, welcome to class. I'm going to talk about alkanes. Alkanes is found in hydrocarbons. Then we talk about hydrocarbons. Hydrocarbons are a group of, or these are the series of carbons and hydrogen atoms that are surrounded by bonds. The bonds can be either single, double, or triple bonds. Here we want to talk about, and hydrocarbons are classified into three groups. The first group is alkanes. The second group is alkenes. And the third group is alkynes. Now, I'm going to talk about alkanes. In my presentation, I'm going to present about alkanes, as I've done the introduction part of the hydrocarbons, or organic chem 1. That's organic chemistry 1. So I'm going to the table of contents. The table of contents, there's about alkanes as saturated hydrocarbons, list of alkanes and its structures, visco properties of alkanes, alkanes formula and its condensed structure, branched chain alkane formula. So this is what I'm going to talk about in my presentation. That is, alkane as saturated hydrocarbons. And the saturated hydrocarbons, these are carbons that have a single bond. That is alkanes. We will see tukisonga mbele. Now let's go to the definition of alkanes. What are alkanes? What are alkanes? Now we will see the definition of alkanes. Alkanes are organic compounds that consist of a single bonded carbon and hydrogen atoms. Alkanes are organic compounds that consist of a single bonded carbon and hydrogen atoms. The formula for alkanes is CN H2N plus 2. Let me repeat. The formula for alkanes is Zn HN2 plus 2. These alkanes are also subdivided into three groups. We have chain alkanes, we have cycloalkanes, and branched alkanes. For example, like my presentation, we will talk about chain alkanes, and the other two cycloalkanes and branched alkanes will come out of the chain alkanes. As we have proved the definition, now the next what we will look at is about the examples of these alkanes. We look at the examples of these alkanes. And the examples of alkanes, we have methane, we have ethane, we have propane, we have butane, we have pentane, we have hexane, up to decane. We can count 10. Let's start. Methane is number 1, followed by ethane number 2, followed by propane number 3, followed by butane number 4, followed by pentane number 5, followed by hexane number 6, heptane number 7, octane number 8, nonene number 9, and decane number 10. Remember our formula. Our formula was Cn H2N plus 2. For example, like methane is number 1. We assume our N is 1. Then we place it where Z is, where N is. So it will be CH4. When we come to ethane, ethane is number 2. We will place it where N is with 2. We place where N is with 2. So you will get C2H2N. That is 4 plus 2. That is 6. So it means as you increase the number of carbons, then as you increase the number of carbon atoms, the number of hydrogen atoms also continue to increase. That one must be considered first, must be considered. Now, we want to look at alkanes as saturated hydrocarbons. We want to look at alkanes as saturated hydrocarbons. We want to look at alkanes as saturated hydrocarbons. Alkanes as saturated hydrocarbons. These are compounds that contain carbon and hydrogen atoms with a single covalent bond. Alkanes are a series of compounds that contain carbon and hydrogen atoms with a zinc covalent bonds. These are also known as saturated hydrocarbons. So saturated hydrocarbons are the ones that contains only a zinc bond. The other two types of hydrocarbons, that is alkenes and alkynes, they are unsaturated. The reason why they are unsaturated is because they have more than one bond. They are carbon-carbon or carbon-hydrogen might have two, or it has two, or a three double bond, or a triple bond. That's why they cannot be saturated. They are unsaturated because of the presence of many bonds. This group of compounds consists of carbon and hydrogen atoms with single covalent bonds. Also comprises a homologous series having a molecular formula. We have said it, that is Cn H2N plus 2. Alkanes are the simplest hydrocarbons. They contain only carbon and hydrogen. Each carbon atom forms 4 bonds and each hydrogen atom forms 1 bond. Yes, carbon and hydrogen. Each carbon atom must form 4 bonds. Carbon is surrounded by 4 bonds, and each hydrogen atom is surrounded by 1 bond. Remember, that 1 bond, the covalent bond, it represents 2 electrons. It presents 2 pairs of electrons. Remember, hydrogen, it needs 1 electron to gain stability. At the same time, carbon, it needs 2 electrons. It needs 4 electrons to gain stability. So it must be surrounded by 4 hydrogen atoms for it to gain what we call stability. Remember, if 1 covalent bond, it is 2, and the carbon is surrounded by 4 covalent bonds, so that these 8 electrons, and the carbon has gained what we call stability. At the same time, hydrogen also has gained what we call stability. Now we can call it octet electrons, octet elements. Chemists use the right angle formulas because they are easier and faster to draw than condensed structural formulas. Structural formulas for alkanes can be written in yet another condensed form. The simple alkane methane contains one carbon atom and 4 hydrogen atoms. Methane, remember we said is our number 1. And if we place with 1, so you will get C1, that is CH4. And that is the molecular structure for methane. The other ones follows. As you move from methane to decane, the number of hydrogen atoms and carbon atoms, it increases using the formula as it stated earlier. Structural formulas for alkanes can be written yet another context for the simple alkane. The simple alkane methane contains one carbon atom and CH4 as its molecular formula. As these compounds have just single covalent bonds only, therefore, its structural formula is CH4. In long-chain alkane, molecule addition carbon atoms are attached to each other with the help of a single covalent bond. Each atom is attached to the sufficient hydrogen atoms to develop a total of 4 single covalent bonds. The long chain structure is known as octane. Octane is number 8. If it is number 8, so it means we have C, carbon are there 8, hydrogen are 18. Using the formula. Remember, we are dealing with the formula at the same time, the type of alkane that is there. If you are given propane 3, remember, N is 3. So if N is 3, where N is, we place it with 3. So if we place 2N, that is 6 plus 2, that is 8. Then let's come to, after we have looked at this, let's come to physical properties of alkanes. Physical properties of alkanes. These alkanes, they have physical properties. And what are the most physical properties of these? We will look at the solubility of alkanes. Does alkanes are soluble or insoluble? That one will be answered. Yes, alkanes are insoluble, but soluble in organic solvents. Since they are nonpolar solvents. Due to very little difference of electronegativity between carbon and hydrogen. Remember, the electronegativity between hydrogen and carbon, it is very little, it is very less, it is little. It has the carbon and the hydrogen, they have very little electronegativity. The covalent nature of carbon and carbon-hydrogen bond, alkanes are generally nonpolar molecules. Remember, these alkanes are generally nonpolar molecules. As we generally observe, polar molecules are soluble in polar solvents, whereas nonpolar molecules are soluble in nonpolar solvents. Hence, alkanes are hydrophobic in nature. That is, alkanes are insoluble in water. However, they are soluble in organic solvents. However, they are soluble in organic solvents as the energy required to overcome the existing van der Waals forces and generate new van der Waals forces is quite comparable. The boiling point and the melting point of alkanes. Now we want to look at the boiling point and the melting point of alkanes. Remember, the melting and the boiling point of alkanes increases from methane to decane due to increase the number of molecular weight. Remember, the molecular weight for methane is 8, and the molecular weight for ethane is 2, that is 8 plus 4, that is 12. So you can see there is a difference in mass. They have different masses. That is why they have different melting and boiling point. Methane, it boils faster. Methane boils faster, followed by propane, up to decane. So the boiling point of alkanes, as the intermolecular van der Waals forces increases with the increase of the molecular size, or the surface area of the molecule, we observe the boiling point of alkanes increases with increased molecular weights. The strength chains, alkanes, are observed to have higher boiling point comparison to the structural isomers. So long chain alkanes, the straight chain, that's long chain alkanes, they have higher boiling point than what we call isomers. Isomers, those are branched chain alkanes. The melting point of alkanes for the stream thread as their boiling point, that is, the increase with increase in molecular weight. This is to attribute the fact that the higher alkanes are solids and it is difficult to overcome the molecular forces of attraction between them. It is generally observed that even-numbered alkanes have higher trending melting point in comparison to odd compared alkanes, as their even-numbered alkanes back well in the solid phase, forming a well-organized structures with difficult to break. Now we want to look at alkanes formula and the condensed structure after we have proved the physical properties of alkanes. Now we want to look at alkanes and formula, condensed structure. Structural formulas for alkanes can be written in condensed form. For example, the structural formula of pentane contains 3 methyl groups, contains 3 CH2 methyl groups. For pentane, remember it's number 5. If it is 5, that is C5H12. And if we are going to condense it, we will have CH2, 3 CH2. Since the first one will take CH3 and the last one will take CH3, the remaining in between the C3, so the 3C, the 3 carbons, they are bounded by CH2 since the carbon is bonded. For example, I've given an example here of propane. That is CH3H8. That is molecular structure of propane. Now, in the condensed one, we have CH3, CH2, CH3. If you look at here in between, it has the condensed structure here. It has CH2, 1. That is propane. Propane is number 3. So it has 1. When you go to butane, it has 2. When you go to pentane, it has 3. When you go to hexane, it has 4. Until you reach to decane. Yes, this is according to my presentation. Now, so we have looked about alkanes and alkanes. These are the structures, that are formed between a carbon and hydrogen atoms and are surrounded by a zinc covalent bond. We have looked at the examples of alkanes. We said we have methane up to decane. We came to look at the physical properties of alkanes, whereby we said they are insoluble in water, but soluble in organic solvents. Due that they are nonpolar solvents. Alkanes are nonpolar solvents. We came to look at what we call the melting and the boiling point of alkanes. We say that the melting and the boiling point of alkanes, it increases as the molecular weight increases. That is the mass. If the mass of the certain alkane is higher, it must have what we call higher melting and boiling point. That shows that these alkanes are really generally solids, and it needs a lot of heat for it to break the bond, to break the covalent bonds that is in between hydrogen and the covalent atoms. Then we have come to look at the alkanes formula and the condensed structures. We have come to look at the alkanes formula and the condensed structures. The structural formula for alkanes, we said it is, the formula for the alkanes, we said it is CnH2n plus 2. That is the formula of these alkanes. We looked at the condensed structure, the molecular structure of alkane, for example, like propane. It is C3, that is carbon, it has 3 carbons and 8 hydrogen. And remember, from methane to a decade, the number of carbons increases with increase the number of hydrogen atoms. Then condensed structure, we have C3, CH2, CH3. The reason why we have CH3 here, remember, this is carbon is supposed to be bonded by 4 bonds. So this it is bonded with another carbon. We can say that is the bond. And these 3 hydrogen atoms, it is going to bond carbon so that it can gain the number of bonds that it needs. It needs 4 bonds. At the same time, hydrogen, it needs only 1 bond, 1 bond. And we say that the 1 bond, it contains 2 electrons. Thank you for listening to me. Let's meet the next class.